Okay, this is the M1 paper from June 2024. It's question number 5, and as we can see by looking at it, this is a kinematics question. It's vertical motion under gravity, but it's quite a complicated question. So what I'm going to do slightly unusually is I'm going to take all the information you can see there and draw out a diagram that I wouldn't necessarily have as part of my answer, but it's more to explain to you guys exactly what's going on. So give you time just to read through all the information that's there. But basically, we've got this parachute box being dropped out of a helicopter. It's 520 meters above the ground. It falls under gravity for 5 seconds, so G is going to be minus 9.8 for that. But then a parachute opens up, so we'll have some force diagram to work out what the new acceleration is going to be. Then it carries on falling till it hits the ground, okay? So it tells me the mass of the box and the parachute. But it then asks me some questions. So before I do any of the questions, I'm going to write this down in red, just so you can see this would not normally be part of my answer. But what I'm going to do is I'm actually going to say, we've basically got this situation followed by this situation here, where I'm going to say from A to B and then from B to C, this total height then here was 520 meters. But from A to B, that's when the acceleration is just going to be due to gravity. G, we know that the U up here is equal to 0. We know that there'll be a V down there, but I'm going to say that's also the same as the start-off speed for the second part of motion there. For that part of motion, I don't know what the acceleration is for this yet, but I'll get it from F equals ma with a force diagram, etc., etc. I'm not going to do that. I'm not going to do all the details of that yet. And then obviously it's finally going to hit the ground here. So I'm going to consider my first part of the journey as being from A to B, and then the second part of my journey as being from B to C. This point here is where the parachute opens, okay? So let's have a look at that and see what we've got there. We know that it's 5 seconds for the first part. We don't know how long it is for the second part. We don't know much information about the second part at all. So now if I was going to be actually having a go at doing the answer, I would say, right, part A, for journey with acceleration equal to G, I'm going to say we have this, so the purple bit would be my actual answer. I'm still going to call it A and B here. I'm going to say U is equal to 0. In fact, let's just do the SUVAT. I'm going to say S, U, V, A, and T. And what they're asking for in the first part, let's just go back and look at the question. They want the distance fallen to start off with, okay? So if they want the distance fallen, then that's going to be my S. I know U is equal to 0. V, I've got no idea what that is. A is acceleration due to gravity, G, and we know it takes 5 seconds there. So if I want to work out S, U, A, and T, it's absolutely no problem at all. I can use one of my kinematics formulae, SUVAT, S equals UT plus half AT squared, and just put the information in. So S is going to be equal to 0 plus a half G. In fact, I'm not going to write half G, I'm going to write 4.9. I know what half G is. So 4.9 times 5 squared. S works out to be equal to 123 meters, or rather 120 meters, because it should be to 2 significant figures. So that's the answer for that first part there. I'm taking downwards as being positive because the motion is just downwards all the way. I'm taking that way as being positive throughout my answer here. Now, the second part says, can we find the speed with which it lands on the ground? So I need this bit of motion here. But for this bit of motion here, I haven't got anything. I don't know what my acceleration is. I don't know what my U is. So I've got to go through and find those things before I can work out part B. So for part B, I've got to do some pre-work, and I'm going to say from A to B still, we need v. So if we go back, we can just use v equals u plus at for this scenario here. Okay, so v is equal to u plus at, so v is going to be equal to 0 plus 5 times g, so v works out to be 49 meters per second. That's now going to be my u for the second part. From B to C then, for that second part, what I need to do is to work out the acceleration. So we need to say we need the acceleration. What I can do up here is just say this is u for B to C. Hopefully everybody understands that whatever speed I'm hitting with here, when I'm looking at this new part, this is the same speed there. So that's all we've said for the last thing that I've worked out. But we need to find the acceleration for B to C, and we need to do the simplest of force diagrams. What have we got going on? They told us in the question, well, we know we've got mg going down, and I'll have a resistance force, a frictional force going up there, but we know what both of those are. mg is 250 g, and they told me that r was equal to 3,200 newtons. We know that the acceleration is going in that direction. So what's going to go on if I resolve vertically? I'm going to get F equals ma. I'm going to get 250 g minus the 3,200 is equal to mass times acceleration, is equal to 250 times this acceleration. This is what I want. I want to work out what that acceleration is. If you rearrange that, then we get that the acceleration works out to be equal to -3. And absolutely that makes sense. Yeah, the whole point about the parachute is it starts slowing it down. So whereas we did have acceleration of g, we've now got an acceleration of -3. It's a deceleration. It's slowing it down. So in this journey now, in this part now, I've got all the SUVAT, hopefully, that I need to be able to work out the speed. We're trying to find v. We're trying to find our final speed. So SUVAT now what do we have? Well, the distance that it's going, I guess I could just go back and say that. We just found that this distance here was 123. So this distance that's left there is going to be 520 minus 123. And I put 123, but use the exact values that you had on your calculator. So 520 minus 123 actually gives us, I think it's 397.5 when we're using the correct values here. We know that our final velocity, which was 49, that 49 is going to be the initial velocity now here. V is what we're looking for. We know the acceleration is -3 there, so I'm not interested in t. I've got S, U, V, and A, so that's v squared equals u squared plus 2as. So v squared equals u squared plus 2as. With all the information that we've got, v squared is 49 squared plus 2 times -3 times that 397.5. Use all the exact values that you had for any of these calculations, previous calculations. You just work out the final bit at the end. And I've done that already. That actually, when you calculate it, v works out to be equal to 4 meters per second. Perfect. Okay, let's have a look at part C. Part C says, can we find the total time from the instant when it's dropped to the instant when it hits the ground? So we want the t for the whole of the journey there. We know it's t equals 5 while it's under free fall, while it's under gravity, but we've now got to work out our t here and then add 5 on, haven't we? So let's make that clear to the examiner. Let's do that here, part C. For total time, and again, from A to B, we already know that. T equals 5 seconds. From B to C, We can go back and use all the information from that SUVAT now. So we can use v equals u plus at, because I knew that v was 4, I knew that u was 49, I know that the acceleration was minus 3, so we can work out what t worked out to be from that. Works out to be equal to 15 seconds. So total time equals 5 plus 15 equals 20 seconds. Perfect, just the last part to do. The last part says sketch the speed time graph for motion from the instant when P is dropped from the helicopter to the instant when P lands on the ground. So let's just think about this. What we've got is that for the first part of the motion, for that part of the motion there, we'll have a constant acceleration of 9.8. We know it's going to go from 0 to 49 there. And then after that, for the second part of the motion, for this part of the motion, we know it'll have a deceleration. It's slowing down with a gradient of minus 3. And we know that the total time is 20 seconds. We know that the final velocity will be 4 meters per second. So I just need to put all that information in. That sounded like a lot when I was saying it. Hopefully it'll make a little bit more sense when we're drawing this out then. So we've got this situation here where we go from u equals 0 to u equals 49 meters per second. This is speed and this is time. We know that took 5 seconds. Then we know it decelerates, and when it decelerates it can't be as steep as when it accelerates. We know that goes to a speed of 4 meters per second there, and we know the total time is 20 seconds. That's more than enough information then to be able to answer that question. Okay, long question there, but hopefully that all makes sense to you all.